Welcome to qnawire.
Hi, so over here we're given the case in which a photon with wavelength 93.8 nanometers strikes an hydrogen atom and light is emitted by the atom after this excitation occurs. Using the following figure, what is the maximum number of emission lines that could be observed? Show how you obtain this number, and we want to know this considering the following hint. Any transition with energy equal to or less than the incident photon is going to be possible. First of all, let's remember that the energy of the photon can be related to the frequency that we're going to get or to the wavelength as hc over lambda. So, any transition with an energy equal to or less than the incident photon is going to have a wavelength associated that is going to be larger than 93.8 nanometers, larger or equal. So the process is going to be the following. We're going to start at n equal 1, then we're going to have the excitations going into n equals 6, n equal 5, n equal 4, and all of the possible excitations corresponding to energies that are lower to this value. As such, the number of lines that we're going to be able to see are going to be the following. We're going to have, first of all, line 1 is going to be the one shown up here, line 2, line 3, line 4, and line 5. Next up, we're going to have the next series are going to be 6, 7, 8, 9. And next up, 10, 11, and 12. We're not going to be able to have excitations, for example, over here from n equal to infinity towards n equal to 3 because the incident photon is only going to allow us to go all the way up to n equals 6. So for that reason, we are not going to be able to see any transitions going from a higher energy level towards a lower value. Now, over here, we're just considering all of the transitions on the series that are being shown. But in addition to that, I'm going to extend the lines over here. We could have as well transitions going from n equal to 6 to n equal to 5, from n equal to 6 to n equal to 4, and from n equal to 5 all the way to n equal 4, which would be three additional ones that we may consider. Just as a curiosity, the two ones over here are going to be named the bracket series, are part of the bracket series, and the corresponding wavelengths are going to be, in this case, from n equals 6 all the way to n equal 4 is 2625 nanometers. Let me put it in red, sorry, in black, 2625 nanometers, 2625 nanometers, and from n equal 5 to n equal 4, it is going to be 4051 nanometers. And this small guy over here corresponds to something that is going to be called the Funt series. Let me change colors because and the transition is going to be equal to 7460 nanometers. I'm going to write it down over here for transition from n equal to 6 to n equal to 5. And with that, it would be all of the possible transitions that we're going to get. And with that, it would be all. Thank you very much and have a good one.